Welcome back, guys. I'm getting a pressure question 2, paper 2. Let's start. Question 2. Figure 8.1 shows a water manometer. When the water manometer is connected to a sealed container of gas and the tap is open, the water level change as shown in figure 8.2. आपको ये पढ़ने की जरूरत नहीं, मैं आपको समझा रहा हूँ. पहले हमें ये वाटर मैनोमीटर दिया हुआ है एंड इसमें सेम प्रेशर लग रहा है ऑन बोथ साइड्स बिकॉज द सील्ड कंटेनर और इसका जो गैस टैप है इट हैज नॉट बीन ओपन येट. So इधर सेम प्रेशर लग रहा है, so there will be no change in water levels. The water levels on either side will be the same. On in the figure 8.2, what happens is that the gas tap is opened, and since the pressure here is much larger than the pressure here, the water level rises on this side and it is lowered on this side. So the pressure will be equal to the weight of the water on this side. क्योंकि weight is pushing the water downwards, right? क्योंकि gravitational force pulls the water downwards while the pressure is pushing it upwards. While the pressure is pushing it downwards. While the water wants to go upwards, the pressure is pushing it downwards. So that is a balanced सिस्टम. ठीक है ना. बैलेंस सिस्टम ऐसी है क्योंकि इतने ही ज्यादा प्रेशर है कि इट इज पुशिंग द वाटर डाउनवर्ड्स ऑल्दो द वाटर वांट्स टू कम अप. अगर ये आपको समझ आ रहा हो आगे आओ. लेट्स प्रोसीड. अगर नहीं आया तो आप इसको फिर से जाके सुने. डिफाइन द प्रेशर. डिफाइन प्रेशर. प्रेशर इज फोर्स डिवाइडेड बाय एरिया. वेरी सिंपल. प्रेशर is equals to force divided by area. Very easy. Let's move on. Explain why the water levels are same on the both sides of the manometer. I have told you because initially both the pressures are same on either side. The pressures are same. That's why the water level has no differences. Sorry. तो ये भी कर लेते हैं for हाँ. Let's do these at the same time. अच्छा, this is B1. तो B1 pressure. Pressure is the same at either side of the water, either end of the water. Left side is at atmospheric pressure. अच्छा, this is B1. अच्छा, B2 पे चलते हैं. Explain why the water level change when the gas tap is opened when the with the manometer connected. अभी मैंने आपको क्या बताया था कि pressure on this time is much larger. This side is much larger than this side because आपको जो मैंने बताया कि गैस का जो प्रेशर है on this side is larger than that side. तो प्रेशर इज लार्जर इन गैस देन दैट ऑफ एटमॉस्फेरिक प्रेशर. ठीक है ना. ओके. मूविंग ऑन. पार्ट 3. एक्सप्लेन व्हाई द वाटर लेवल स्टॉप चेंजिंग एट द लेवल शोन इन फिगर 8.2 एज आई हैव टोल्ड यू. इसको हटा देते हैं. सो देयर इज सीन अ 40 सेंटीमीटर डिफरेंस बिटवीन बोथ ऑफ देम, राइट. 40 सेंटीमीटर का डिफरेंस है. दैट मींस 40 सेंटीमीटर ऑफ वाटर इज इक्वल टू द प्रेशर ऑफ द गैस. The pressure caused by 40 centimeter of water is equal to the excess pressure caused by the gas. अच्छा, मैं आपको समझा देता हूँ. There is an opposing pressure caused by the water as well, जो अभी मैंने आपको समझाया था. But due to the pressure of gas being larger than that of the pressure of water, that's why the water is been pushed downwards and risen up here, right? So that means के only 40 centimeters of water can be मतलब मेंटेन हो सकता है by the pressure of gas in this gas cylinder container. So that is that. The water in the manometer has a density of 1000 kilograms per cubic centimeter. Density 1000. अच्छा, atmospheric pressure is as always 100,000 because we're on the ground. So atmospheric pressure is 100,000 and the gravitational field strength is G, which is 10 meters per second, 10 newtons per kilogram. So G is 10. Calculate the pressure of the gas inside the sealed container. Very simple question. We're going to apply the formula. Pressure is equals to rho GH. Rho will be density into G, which is gravitational field strength, into H, which is height. But we'll have to add the atmospheric pressure in the start in order to find the sum of it. Atmospheric pressure plus rho GH in order to find the pressure. The pressure of the gas inside the sealed container. Because either side पे atmospheric pressure लग ही लग रहा है. The gas is producing an excess pressure. ठीक है ना? Gas is producing an excess pressure. यहाँ भी atmospheric pressure लग रहा है और इधर भी atmospheric pressure लग रहा है. So उन्होंने हमसे पूछा है कि टोटल प्रेशर कितना है, राइट? तो इधर 100,000 लग रहा है और इधर फॉर एग्जांपल 110,000 प्रेशर लग रहा है, राइट? So we don't have to find the 10,000, we have to find the total 110,000 pascals. So निकाल लेते हैं. AP is plus density which is 1000 into G which is 10 into H which is, I forgot what the H is. It's 40 centimeters. 40 centimeters in meters is 0.4. That will give us an answer of 4,000 plus atmospheric pressure which is 100,000 additional pressure. So that will give us 104,000 pascals. ठीक है ना? So that would be the pressure. देख लेते हैं 104,000 pascals. As I told you, you have to add the atmospheric pressure because that is a constant on either side. And they have told us to calculate the pressure of the gas inside the sealed container. And जब उन्होंने एक वैल्यू दी हुई है ना, तो that value is gonna come in use in either way. ये वैल्यू यूज में आनी ही आनी है. ऐसे नहीं हो सकता कि वो वैल्यू एम ही दे दें हमें. अच्छा, the temperature of gas inside the sealed container increases using the ideas about molecules explain why the water level changes. अच्छा, अब मैं आपको एक कॉन्सेप्ट समझाता हूँ. दिस इज अ वेरी रिपीटेड कॉन्सेप्ट, तो मैं I'll try to keep it short. तो फॉर एग्जाम्पल these are a few particles inside a gas container, let's say. ठीक है ना? गैस कंटेनर में there are a few particles. So when heat is provided, what is provided? The energy is provided to the particles. When heat is provided, energy is provided, or that energy will be kinetic energy. And when the particles have kinetic energy, they will move fast and hit the container more. And when they hit the container more, they will apply more pressure on the container. I'll repeat it once again. जब इनको एनर्जी मिलती है, the kinetic energy will increase the speed of the particles, and as they hit the container they will produce a higher pressure which will cause in that which will cause that, right? So about the level change. और जब there will be a higher pressure, तब obviously अगर यहाँ है, sorry, अगर यहाँ कुछ particles हैं, so obviously they'll hit the container as well. And when they hit the container, they will produce a pressure which will push the water down and it will come up here. So very basic concept. So yeah, this is the answer. So they will hit the surface of the water more, and when they hit the surface of the water more, they will produce a pressure. When they produce a pressure, the water will go down and up the other side. So let's copy this and paste it here. Part E1. The manometer is not suitable for measuring a gas pressure of 2.5 into 10 raised to the power of 5 pressure pascals, I mean. Explain why. Explain why, because the manometer is not large enough to hold that type of pressure. अगर यहाँ से इतना pressure लग रहा हो, इतना pressure लग रहा हो, that the gas will overtake the whole tube and all of the water will flow out. ठीक है ना? All of the water will flow out. So that is why the ये है 250,000 pascals. That means an additional, other than the, what do you call it, other than the atmospheric pressure, there is an extra 150,000 pascals. There is an extra 150,000 pascals which will produce a height much larger than that of the manometer. Manometer can only support a height of 690 centimeters, while this pressure will produce a height of much larger than 90 centimeters. So this is not optimal for this manometer. इसके लिए आपको आई थिंक अगले चैप्टर क्वेश्चन में यही आ रहा है. I'll explain it there. Pressure much bigger than atmospheric. Extra pressure above atmospheric of 1.5 into 10 raised to the power of 5. Difference in height of manometer level needed to large. Acha, difference in height. Yeah, manometer tubes too short. Water comes out of the manometer exactly like I told you. State one change to this manometer that allows it to measure a gas pressure of 2.5 into 10 raised to the power of 5 pascals in a normal school laboratory. अच्छा, normal school laboratory में अगर हमने करना है तो we'll need to have a manometer which is small in size. अगर एक manometer is small in height, then there is another variable factor which can depend, which can मतलब differ the pressure, which can combat the pressure of the gas of 250,000 pascals, which is the density of the liquid. अगर density of the liquid is more, then the pressure created by the liquid will be more as well. And when the pressure created by the liquid is more, that will be able to combat the pressure of 250,000 pascals. आप इस मैनोमीटर को भी थोड़ा सा बड़ा कर सकते हो, लेकिन द मेन डिफरेंशिएटिंग फैक्टर इज द डेंसिटी ऑफ द लिक्विड. अगर आप डेंसिटी ऑफ द लिक्विड को इंक्रीज करोगे, द प्रेशर कॉज्ड बाय द लिक्विड विल बी मच मोर लार्जर देन इट इज राइट नाउ. सो या, so that is it for this video. I hope you enjoyed. Thank you for watching. Allah Hafiz.